Hello everyone, myself Pradeep Rani, PGT Mathematics from JNV Chandigarh. Welcome all of you here. Dear students, today I am here to let you know about chapter number 3, Coordinate Geometry. Dear students, in this chapter we will know about the need of coordinate geometry, discuss about various activities from our routine life related to coordinate geometry. We will come to know about the history of coordinate geometry. Then we will learn about Cartesian system, axes and quadrants. And at the last of this chapter, we will know how to plot the points on a plane if their coordinates are given to us. First of all, in this chapter, we come to know about the need of the coordinate geometry, that is, why coordinate geometry? To locate the points on the paper. Next one is maps are also based on the coordinate geometry. Construction field also requires coordinate geometry. In the finance sector, to draw the graphs, we need coordinate geometry. Various subjects like astrophysics, chemistry, molecules, aeroplane navigation, coordinate geometry is required. Dear students, if we come to your era, then to create animations as well as video games, again coordinate geometry is required. If we come to the medical field, then to have MRI, X-rays, CT scan, again coordinate geometry is required. So in the nutshell, we can say that coordinate geometry is too much useful to us in the various fields of our routine life. We come to have a situation from our routine life. Dear students, in the adjoining figure, there is a main road which is running in the east-west direction. East-west direction, you can see in the figure, this is the east-west direction and there is a road on this direction in which street numbers are marked either above this road or below this road by numbers 1, 2, 3, 4, etc. up to 8. And these streets are having the house numbers marked on it like 1, 2, 3, 4, 5, etc. Now, what activity we are going to do is, if we have to look for a friend's house here situated in the street number 2 and house number 5, then what we'll have to do? We will have to locate first street number 2. This is the street number 2 which I am pointing out here. Then we come across the number of houses 1, 2, 3, 4 and 5. It means to say this point H represents the friend's house which is numbered 5 located in street number 2. Next, similarly, we can see that this point P is representing a house number 4 marked in street number 7. Now we come to know for the location of a point. Dear students, if you put a dot on a sheet of paper and you have to tell its location, then we will say that either it is on the left edge of the paper or it is on the right edge of the paper or it is in the upper half of the paper or it is in the lower half of the paper. But it will not fix the position of the dot precisely. Now what we will have to do to locate it precisely, we will be in the requirement of two independent transformations. For example, if you can see in the adjoining figure, the dot is nearly 5 centimeter away from the left edge of the paper and 9 centimeter above the bottom line of the paper. It means to say we will have one more interesting activity to make it more precise, more clear. The activity is known as sitting plan. It's a classroom activity. What we do, draw a plan of sitting in your classroom by putting all the desks together, representing each desk by a square. You can see in the adjoining figure. Now, these benches are arranged in square shaped and each are put together. Then what you have to do is write the name of the student occupying the desk in each square. For example, if we take Sonia, which is being represented here by point S, means name S, she is occupying the position 4, 1, and the filled block, this one blue colored filled block, is representing the position 5, 3. We can say that for this, the position of each student in the classroom is described precisely by two independent informations. One, first number is the column in which she or he sits, and the second one is the row in which she or he sits. From the above situations and activities we discussed from our routine life, we can conclude that position of any object lying in a plane can be represented with the help of two perpendicular lines. Only this idea gave rise to a very important branch of mathematics known as coordinate geometry. Now, what is the history of coordinate geometry? Dear students, René Descartes, he was the great French mathematician of the 17th century. He solved the problem of describing the position of a point in a plane. He got this idea from the idea of latitude and longitude. In the honor of Descartes, the system used for describing the position of a point in a plane is also known as the Cartesian system. Now, what is Cartesian system? All of you have read about chapter number system, and on the number line, equal distances from the fixed point, that is we say origin, that is 0, are marked positively in one direction and negatively in the other. If we see the number line, in the right direction we always take the positive numbers, and in the left direction we always take negative numbers from 0. The point in the positive direction at a distance r units from the origin represents the number r, and the point in the negative direction at a distance of r units from the origin represents the number minus r. Dear students, you can make it more clear by observing the figure given here. Origin is there and the positive numbers are marked on the right hand side and the negative numbers are marked on the left hand side of origin, that is 0. Now, what are axes in the Cartesian plane? Descartes invented the idea of placing two such lines perpendicular to each other on a plane such that one of them is horizontal. Dear students, I am marking here horizontal line and the another one is vertical line. Horizontal line is marked by x dash x and vertical line is marked as y dash y, as you can see in the figure. Now axes and quadrants of a plane. Observe that the axis, which is a plural word of axis, axis, divide the plane into four parts named as quadrant 1. This you can see here, quadrant 1. Next one is quadrant 2, another one quadrant 3, and last one is quadrant 4. You can see that they are marked in the anti-clockwise direction starting from the position OX. Now, so the plane consisting of the axis, both of these axes, x-axis as well as y-axis, and the quadrants is called the Cartesian or the coordinate plane or xy plane. The axes are called coordinate axis. X-axis as well as y-axis, they are called coordinate axis. Now we come to know about the signs of x and y in different quadrants. Dear students, as you are observing that quadrant 1, I am pointing out here, quadrant 1 is named as XOY, and in this quadrant x and y both are positive. In the second quadrant, x dash OY, x is negative, y is positive. Now in the third quadrant, we are observing x and y both are negative, and last fourth quadrant, we can see that x is positive and y is negative. What are abscissa and ordinate? Dear students, in the adjoining graph, you find that the perpendicular distance of point P from y-axis, I am pointing out here, perpendicular distance of point P from y-axis measured along positive direction of x-axis is given by Pn, which is also equal to MO or OM, you can say that, and this distance is 4 units. The perpendicular distance of the point P from the x-axis, distance of the point P from x-axis, this is, I am pointing out here, PM, measured along the positive direction of y-axis is equal to, PM is equal to NO, or you can say ON, and this distance is 3 units. The perpendicular distance of point Q, if we come to the point Q here, the perpendicular distance of this point from y-axis measured along negative direction of x-axis is 6 units and is also equal to distance RO, which is equal to XS, or you can say OR also. This is 6 units. And next, if we take the perpendicular distance of the point Q from the x-axis measured along negative direction of y-axis, this is QR equal to SO, or you can say that OS. This is again, we can say 2 units. So what we conclude? The x coordinate of a point is perpendicular distance from the y-axis measured along x-axis. Now, if we come to the point P, it is 4. This is 4 units. And for point Q, it is 2 units. Sorry, minus 6. So, the x coordinate is called abscissa. If we come to the y coordinate of a point, it is perpendicular distance from the x-axis measured along the y-axis. Now for the point P, this is 3 units. You can see here 3 units, and for point Q, it is 2 units. But because it is in the negative direction of y-axis, so it is having the coordinate equal to -2. So the y coordinates are called ordinates. In stating the coordinates of a point in the coordinate plane, x coordinate comes at the first position and then comes the y coordinate. Coordinates are placed in open, that is we can say round brackets. For example, we can say that coordinates of the point P are 4, 3 and the coordinates of the point Q are -6, -2. Dear students, every point on the x-axis has 0 distance from x-axis. So, the y-coordinate of every point lying on the x-axis is always 0. That is, we can say that coordinates of every point on x-axis are of the form x, 0. Similarly, coordinates of every point on the y-axis are of the form 0, y. Now, what are the coordinates of origin? Origin has 0 distance from both the axes so that its abscissa and its ordinates are both 0. So the coordinates of the origin are defined as 0, 0 as you can see in the adjoining figure. Dear students, from the knowledge you gained, you can solve this example. You can see in this adjoining graph that the coordinates of the point B, you can see here I am pointing it. The coordinates of the point B are, since it is in the negative direction of x-axis at a 5 units distance, so its abscissa is -5 and its ordinate, that is the distance along positive direction of y-axis, is 2 units. Means to say, we can say that coordinates of the point B are -5, 2. Similarly, the coordinates of point C are 5 units on the positive direction of x-axis and 5 unit in the negative direction of y-axis. Hence, the coordinates of C are 5, -5. The point identified by the coordinate -3, this is -3, -5, so we get the required point as E. The point identified by the coordinates 2, -4 is the point G. If we come to the point D and we have to know about its abscissa, it is 6 units and the ordinates of the point H, ordinate of the point H is -3. Now if we come to about point L, since it is lying on the y-axis at a 5 units distance in the positive direction, so its x coordinate will be 0. So the coordinates of point L are 0, 5. Similarly, the coordinates of the point M, since this point M lies on the negative x-axis, so its coordinates are at a distance of 3 units in the negative direction. So the coordinates of the point M are -3, 0. Now we are going to learn about the plotting of a point in the plane. Let the coordinates of the given point be 3, 5. We know that x coordinate, that is abscissa, represents the distance of the point from the y-axis. So first we will move 3 units from origin towards positive direction of x-axis, and then y coordinate, that is ordinate, being distance of a point from x-axis, we will move 5 units from that position where we were already standing Now we move 5 units towards positive direction of x-axis and we reached at the point P, which will represent the location of the point 3, 5. Dear students, similarly we can plot the point 5, -4 and many more points in this plane. Now there are some points to be plotted by you people. For example, 5, 0, 0, 5, 2, 5, 5, 2, etc. in the Cartesian plane. I am giving you the solution. Dear students, 5, 0, since it is having its y coordinate, that is ordinate 0, so this point will lie on x-axis at a distance of 5 unit. So this point I am pointing here is representing 5, 0. Next 0, 5, its x coordinate is 0, so this point will lie on y-axis and at a unit of 5 unit in the positive direction of a y-axis. So we come to know about this point which is being pointed as 0, 5. Next is 2, 5. We moved to 2 units towards positive direction of x-axis and 5 units towards positive direction of y-axis and we reached at the point 2, 5. For the plotting of point 5, 2, we will move 5 units towards positive direction of x-axis, then 2 units along positive direction of y-axis and we reached at the point 5, 2. Similarly, we can also plot the other points given to us in this plane. Dear students, from the above example and you can say from the more examples like this, you will come to conclude that if the x and y coordinates are not same, for example, I am pointing, you see point 2, 5 and 5, 2. Since x is not equal to y, so these 2 points are not describing the same position. They are giving us the different positions. So what we will conclude as x, y is not same as that y, x for all x not equal to y and x, y will be equal to y, x for all x equal to y. Now there is a practice for you people. You will have to solve this question: in which quadrant or on which axis do each of these points lie, and verify your answer by locating them on the Cartesian plane. Dear students, you can solve this problem by having or using the knowledge of quadrant system and the axis as well as the plotting of the points in the plane. Means you can conclude whole of the chapter in this problem and verify your solution by locating them on the Cartesian plane. Thank you all of you.